Good afternoon and welcome to the seminar Innovation and Regulation in the Framework of the Energy Transition, where we will analyze the situation and perspectives of innovation in Europe. Accelerating energy-related research and innovation has been recognized as a priority by the European Commission, a priority that stresses the need for a regulatory and financial framework for energy innovation, coherent with the European Union Energy Roadmap 2050 and its commitment under the Paris Agreement. A cost-effective transition towards environmentally friendly, consumer-oriented, and more digitalized and decentralized systems with active consumers and prosumers communities requires research and the deployment of innovation across all energy systems with the participation of all actors, public and private. We'll talk about all these aspects in these seminars with distinguished speakers. We would like to thank all of them for joining us and sharing their vision of the state of innovation in Europe. A seminar within the framework of the European project TransNet, an European research and innovation project that involves different research institutions from Spain, France, and Portugal under the coordination of the Paul Sabatier University. Just to present the more relevant aspects of this project, we have with us George Zisis, Vice Rector of the University and Coordinator of the project. Thank you, George, for joining us, and the floor is yours.
Thank you, Joan. Good afternoon to all the participants. I am George Zisis, and I am the coordinator of TransNet program, and also I'm Vice Rector of Toulouse III University, Paul Sabatier, for international projects. I want to say a few words about the project itself. TransNet project has an objective in strengthening networking and synergetic research and innovation action at the CIDOE transnational level. CIDOE is including the southwest part of France, say from Bordeaux to Montpellier, Spain and Portugal. Inside this project, we aim to creating synergies in Southwest Europe between companies, academic institutions, and technological infrastructures in the service of companies by exploring the opportunity and condition to create academic living labs. Just to give you an idea of the size of the project, we have two partners from Portugal, which is the Faculty of Science of Lisbon University, the University of Beira Interior in Covilhã. In Spain, we have 4 partners with CTA in Sevilla, CIRCE in Zaragoza, Polytechnic in Madrid, and of course, the last but not the least, Funseam in Barcelona. And finally, in France, 2 partners, University of Toulouse III, the coordinator, and the University of La Rochelle, a little bit north of Bordeaux. The total project budget is rather important because it's above 1.5 million euros, and FEDER grant us 75% of this amount for performing our work. Well, as I told you, the objective is to create living labs. What is a living lab? I look for my notes. Yeah, there is. Well, a living lab is globally an open innovation ecosystem which is end-user centered and allows somehow to create public-private partnerships in order to test different products or service in real environment. The idea inside TransNet program is to develop a university living lab model which is generic and transferable to different universities. And of course, we need to focus on ecological transition with mobility, energy, but also numerical networks, environment, and all that stuff. At the end of the project, we aim to finalize this model, including the economic model of such academic living lab, and be ready to submit this model for labeling in different European or international authorities. To achieve those objectives, which are rather ambitious, we have several tools. One is in all of our universities, especially between the partners, we use our campus to demonstrate our know-how. And the idea is starting by transposing some demonstrations from different universities to the other partners. For example, smart lighting from Toulouse in Madrid, use of batteries, second life of batteries from Lisbon to Toulouse and vice versa. This is one tool. The second tool is once we understand how it works, create new demonstrators. And finally, and this is almost the work that Funseam is undertaking, is once we have all that experience, is to see how we can construct an economic, viable, and sustainable model for this type of entities. Well, I think this is all. I will stop here, and if you have questions, you are very welcome. I can stay for a few moments more in that meeting, and then I have to unfortunately, to go to another meeting. Thank you very much.
Thank you, George, for your words and for the details of the presentation of the main aspects of the project. Just to continue with the seminar after this word of welcome, we consider that tackling the challenge of innovation requires an understanding of the current situation and prospects of energy transition. As you know, the energy transition is in the eye of the storm. The future of the planet depends on it, and it represents a great opportunity also for economic recovery after the pandemic crisis, thanks to its capacity to generate and contribute to the GDP. The energy transition requires a major commitment to innovation and technology development to address the technological challenge it poses. A question that is analyzed in the recent study, R&D Overview and Innovation Trends, carried out by CTA, which main conclusions will be presented by Germán López, head of the energy at CTA. Thank you, Germán, and the floor is yours.
Thank you very much, Joan. Thank you, Funseam, and particularly Joan. It's a pleasure to be here with you. And as you said, to provide us the opportunity to share with you the main aspects of the report that you have just mentioned. R&D Overview and Innovation Trends 2021, which we have to take into account that was elaborated by CTA at the beginning of this year. Since then, many things have happened and we are tracking these aspects. As we all know, the COVID-19 pandemic has marked a crucial turning point in virtually all areas, but has been particularly significant in R&D. And I would like to join this to the words established by George, because I think this kind of relationship with the living labs is very important. We have to take into account that the exponential acceleration of digital transformation, growing interest in incorporating new trends that we are going to see now, and disruptive technologies, and a major effort by governments to provide public support are among the key factors that we are addressing. It's difficult to say that there are positive consequences of the pandemic. Of course, there are no positive consequences, but just to mention that there is one thing that we have to take into account that it has been positive, is that it has increased the collective awareness regarding the crucial importance of R&D and innovation, as it has been shown with the capacity of this sector to respond to the pandemic and in that the subsequent reconstruction that we expect to have after the disaster that we are all living. Okay, in order to sum up this presentation, I would like to present you some key aspects that we gather in the field of innovation in 2021 Among these key aspects are the economic situation, the major tech trends, the evolution of R&D, especially in Spain and Andalusia, and regarding the European context. I would like to finish in highlighting different aspects that are related with the current energy transition process that we are involved in. And one key message is that there is a significant need of innovation, a tsunami of innovation that must be developed, as we will see later on, in order to be able to have more chances to reach the goals of the limitation of 1.5 degrees Celsius of our planet. It must be, if we have any chances to reach those goals, will be thanks to innovation, not just deployment of the current technologies, but we will have to move to another technologies. First of all, and as I anticipated previously, I would like to highlight that the coronavirus pandemic has been a shocking event with a great socioeconomic impact. This coronavirus suddenly and surprisingly plunged the world into an unprecedented global recession last year. There was a slowdown in the economic activity due to what we have all faced, lockdown and mobility limitations that have big consequences, as you can see in the graph, where the reduction of the GDP was very high in Spain, more than 10%. One of the worst economies that were hit stronger, as we will see later on. There have been plenty of economic and financial institutions that by the end of 2020 were, let's say, optimistic about 2021 and above all next year, 2022. As we will see later on, these numbers are being modified constantly by these institutions. It's true that the mass implementation of vaccines and the increased knowledge and control of the disease are expected to stimulate economic activity. It's true that a rebound effect was expected to boost our GDP growth, but the experts warn us that different actions should be needed to maintain this rebound effect in the medium and long term in order to restore employment and welfare levels that we had in the pre-crisis time. When we developed this study, the World Bank expected the global economy to expand by 5.6% this year, 2021. And at that time, it was the fastest pace following a recession in 80 years. But it's true that, however, this reactivation by the end of 2020 global production would expect it to be about 2% lower than the projected before the COVID-19 pandemic. And by 2022, per capita income losses will not be reversed for nearly 2/3 of emerging markets and developing economies. This is important as we see that this is not going so fast. With regard to Spain, as we said before, and you can see on the slide, we suffered a 10.2% decrease of the GDP, and which is much superior to the decrease the Eurozone had of 6.3% and more than the United States and the rest of the world. Due to this, probably, as we were in a very bad situation, Spain was expected to particularly benefit from the lower incidence of the pandemic, with the underlying process of vaccination and the implementation of projects under the umbrella of the European Next Generation funds that we expect to come. Most institutions at that time were increasing their growth forecast, and the European Commission, although these years, 5 days ago, they have changed some estimates. At that time, they estimated that Spain would be the fastest growing European economy in 2021. It has not been the case, by the way. At that time, also, the Bank of Spain expected a 6.2% increase in GDP and a little bit lower, 5.8% in 2022. It has been reversed right now. We will see. The International Monetary Fund envisions similar figures, but both institutions recently modified these estimates and now are much lower. In fact, the European Commission, 3 or 4 days ago, they have changed to indicate that our increase will be lower than 5%. Although the good news, if there are good news in that sense, is that the economic expansion is supposed to be just postponed. It will take place, but it will take place later on. In fact, by 2022, next year, they expect that we will grow half a point higher than expected previously, so more than 6%, 6.4%, I think. Although it's out of the scope, and as there are several partners from France and Portugal, it is fair to say that other European countries, as France and Italy, for example, have grown much more than Spain, and they were expecting not to grow as far as now. So that's something we have to take into account, and probably it's because of there are several reasons. One of them is the energy cost, that it has been increased significantly. So we will, to get the pre-crisis GDP level, we will have to wait till the beginning of 2023. We will have to see future developments. I know that there are experts here, as for example Joan, regarding the energy costs, but it's supposed that this will change in spring, something like that. We hope also to take advantage of the European funds, and then this will help us to increase our GDP significantly. Moving from the recovery expectations to the major technological trends, I would like to underscore that innovation is a strategic process in the medium term that requires individual planning for each company, that has to take into account its objectives, sector, and singularities. Having said that, the major general trends and new disruptive technologies are constantly emerging, and you can see that on the slide. And this could help us to take the opportunities and to take advantage of these opportunities and to increase our competitiveness. There are several aspects in this slide that I would like to comment, although we don't have too much time. But regarding the next generation European funds, the companies must be very attentive to these financial opportunities that are coming from the Recovery and Transformation Spanish Plan, that has more than 150,000 million euros for the period 2021 to 2026. And this Recovery and Transformation, and I think it's a resilience plan, it has two main priorities: digital transition and green transition. Both of them are very much related with energy transition, not just the green transition. As we will see, the energy system we are moving to is digitalized, not just decarbonized and distributed, but also digitalized. And there are many aspects from the digital transition that could be used and applied in the new energy system, so that we are moving towards. So we have a good opportunity regarding this economic funds coming from the European Union. If we move in the clockwise, we could see the mobile network revolution. Although this is not so much related to the energy, I would like to highlight some points regarding this, because this increases the connection speed, minimizes web response time, but above all, in the sense that it could affect the energy transition, multiply the number of connected devices. And this is good, for example, in the case of autonomous vehicles, which is related to the energy transition. And these autonomous vehicles could be connected much faster thanks to this mobile network revolution that this is one of the energy trends we are living right now. Digital twin is another one. It's an increasing trend in industry. This consists of generating a virtual replica of a product, and this stimulates the behavior of its physical counterpart. Thanks to that, and we have some examples related to energy industrial processes regarding, for example, refineries, although we cannot provide too much information regarding that due to confidentiality issues, but it speeds up the process of the things they have to develop in the industry. Regarding artificial intelligence, the artificial intelligence, that is the technology that enables machines to make decisions, is being improved constantly, and it's fine-tuned. And this is very much related with big data. There are plenty of data now in the energy installations that we have to manage. This is related also to Internet of Things, and this is very much related with many devices that are being used in the energy efficiency sector and so on. Another aspect that is very interesting regarding these technological trends are the autonomous vehicles or smart vehicles. In this case, I would like to refer especially to the autonomous vehicles because its implementation is a question of months. The application of drones in current energy infrastructures, for example, maintenance of wind energy parks or large PV installations, especially in hard-to-reach areas, is a reality that will continue to spread. The amount of money that is going to be moved in those markets is going to be huge, significantly huge. I would like to say that we have several projects that R&D projects that have been funded by CTA to our companies that have to develop projects in collaboration with research groups from the universities. They have developed several innovations in this field, and they are now being introduced in the market. Regarding blockchain, it's good. Someone could think that this is not very much related to energy, but it's related to energy. For example, we have had now one of our projects coming from one of our partners, NL, that has recently developed a project that applies blockchain to improving the management of economically vulnerable customers. Okay, this is energy poverty, but this is an issue of a special interest right now in Spain, at least. And thanks to this, the town hall can avoid power cuts to vulnerable people and things like that. Bioeconomy and circular economy is another trend we have to analyze. And as I'm running out of time, I would like to move to the energy transition to provide just some aspects that I will delve later on. As the energy transition, as said before by Joan, represents a great opportunity for economic recovery, although we are in the eye of the storm right now. It requires a major commitment to innovation, and this is probably one of the main aspects that I would like to highlight here. As there are many technological challenges that have to be faced, but there are challenges ahead that we still don't know, and there are technologies that haven't been developed yet. There are prototypes, but the reduction of the emissions must be based on those at least 30%. I don't remember if it's 30% or 35% of those emissions that need to be avoided, need to be reduced, are coming from technologies that have not been developed yet. And for that, the effort in technology innovation is huge, and this is something we have to take into account, and it will delve into later. I would like to go to the next one and just to show some expenditure that it has been spent in Spain and Andalusia regarding R&D. And to be honest, in this case, as I'm running out of time, I would say that Spain and Andalusia need to speed up the growth in their R&D investment in order not to lose competitiveness regarding the rest of Europe, which at the same time is not the best. Some of the countries are not the best in comparison to Israel or other countries. It's important that, as it can be seen on that slide that we are going to move immediately, we have to increase the private expenditure on R&D. Next slide, as I'm running out of time, please. And regarding the European innovation context, Spain is in a situation that has to be improved, definitely. Please, next one, as I'm running out of time. And regarding energy transition, next slide, please. Okay. And you can see there that it's very important. There are several aspects that we have to deal regarding the energy transition, but all of the scenarios that we are dealing with state that the implementation of renewable energy sources is for sure necessary. Also, energy efficiency and electrification, hydrogen, and the CO2 removal. This is very important. The energy transition process, as said before, is unstoppable. But in order to obtain the energy system we are moving to, that is decarbonized, decentralized, and digitalized, I would like to say distributed, very much distributed. That is very important in order to improve efficiency. Digitalized, related also to the digital transition that we are also living in. And decarbonization is definitely required. And we have to, we are in a process where electrification, next slide, please, where you will see in this slide that this is the energy consumption in 2018 and 2000. This one, okay, and you can see here that the share of electricity was 21%, but by 2050 it is foreseen that it will be 50% of the final energy consumption. But although this is very important, and this is something that we are all living, that electricity is being used everywhere right now, one of the most important aspects is what is shown at the bottom part of the table, that the renewable share in electricity is right now, it was in 2018, 25%, but it will be 90% by 2050. And that electricity mainly will come not just from renewable, but from intermittent renewable, variable renewable. This means that we have like photovoltaics and wind energy. This means, next slide, please, that we need, as you can see there, the variable renewable energy that we need at that time. We will need a lot of innovation in order to improve storage, to improve flexibility, and the technology is there. The decrease of the cost in PV and wind energy, for example, has been huge during the last decade, more than 80% in the case of PV and around 40-45% in the case of wind, depending on if it's onshore or offshore. And the batteries are going right now a very similar trend, thanks to innovation. And next slide, please. This means that we have many things to be developed in technological aspects, in terms of storage, as said before, flexibility of the grid, in terms of energy security, because energy security is something that we have to keep very clear always. There will be a huge push for hydrogen, although hydrogen will be used mainly in transport, but heavy transport, electric vehicles. There are many things to be done in efficiency, carbon capture, and many renewables. And there will be new technologies that must be developed, and this must be developed thanks to innovation, thanks to the collaboration between companies and research institutes, universities, to get the final goal of the global energy system that must be decarbonized, digitalized, and distributed. Please, next one, I'm gonna finish. And for me, for us, it's very important that we have to take the message that innovation is totally necessary. There are many technologies that are being deployed, although the current pace of deployment is not enough. We still need new technologies, for example, in order to decarbonize the heavy industrial sector. And those technologies rely on the innovation that is taking place today. So this is my message. I'm sorry because it has taken a little bit longer. Thank you very much for your attention, and I'm open to any questions that I could answer. Thank you very much.
Thank you, Herman, for the detailed presentation of the main R&D and innovation trends in Spain and Europe. And let me say that I will keep the last message that I think that is very relevant. And as you pointed out in the study and in the presentation, in short, Spain, Europe must speed up the growth in their R&D investment so as not to lose competitiveness regarding the rest of the world, with a particular focus on increasing private and public investment and expenditure. An issue that we will have the opportunity to discuss in more detail at the next two roundtables. The first one with relevant technological centers in the CIDUE region. Technological centers have a strong relevance given its capacity and potential for providing the disruptive and innovative solutions the energy transition requires. In this first roundtable, as a chairman, we have the pleasure to have Andrés Llombart, General Director of CIRCE, an institution that everybody knows that is since its creation a reference in the transfer of knowledge, developing innovative and energy technological solutions to the industrial businesses. Andrés, thank you for joining us in this seminar, and the floor is yours.
Thank you, Joan. This first roundtable is about innovation and regulation barriers, the vision of the technological centers. I just want to say that technicians, researchers are used to break usually technical barriers. So we are used to break barriers in general, but we have special problems when the barriers are regulatory barriers, and this is the main issue of this roundtable. We have three important speakers, three great speakers. The first one is Manel Sanmartí, that is Head of Corporate Development and Technology Transfer at IREC. Manel has more than 20 years experience leading and participating in national and international R&D projects in the field of energy system. The second one is Andreas Samper. Andreas Samper is full professor and head of the Electronics Group of CICEA, Polytechnic University of Catalonia. Andreas has been involved in numerous European research and innovation projects. He is expert for the European Commission, and his focus lies in the technology transfer to the energy sector. And finally, Damien Vallet is responsible of Totem Platform in CIATEC, the energy research platform of the Occitania region of France. Damien is an expert in technology transfer to industry. So I'm going to give the speak to Manel Sanmartí, and at the end of the speakers, we are going to have a short roundtable with some question for every one of you. Please.
Yeah, good afternoon, everyone. thanks to the moderator and the organizers, especially Funseam colleagues. Very nice and very keen for inviting us to be here today. I will briefly review my overview on what I believe it's a key in terms of bringing new technologies combined with regulation to the energy market. I've been in the introduction. I've been working on energy research for a long time, and lately I just moved to a bit more on the management and technology transfer and trying to tackle on innovation aspects. I try to use a kind of a triangle on how we can transform our energy sector in a three perspectives. Research. We are research, so at the end of the day, we have to base our activities on that. Second, in this respect, how regulation limits or boosts or may help research, or the other way around, how research may boost regulation. And finally, the market, because we need the market, otherwise we need to regulate anything. So market is regulated, and then we may push it forward with research, and we will close the loop with these 3 points. And for me, the innovation is in the middle. Innovation in the technology, innovation on the ways we do research, innovation on the ways we sell it, innovation on the way we regulate, so that we can enable business models. And that's the key point. And that's for me what drives our motion in research today. Out of that, I would say that we at IREC, we are a research center created 10 years ago. We are not a classic research center really focusing on papers and only research and academia. At that time, we were created already with companies. And the idea was bring relevant partners with you from the beginning, from scratch. Otherwise, it will be much difficult. We have universities, so a source of knowledge, which was already there since a long time, and we were young. So you need to bring existing knowledge in there. You need to bring companies, private companies, and you need as well to bring other institutions, administration. And the administration is not only for fiscalizing you; it's administration for exchanging information. Or innovation and research may permeate to administration and the other way around. And this is very important. The first thing, of course, is do the best research you can. You have to be disruptive, because you will change regulation when you disrupt with new technologies. Otherwise, business as usual tends to take the lead, right? And to block things. If research wants to be really disruptive, you need to look for innovative tools, or really something which allows you full freedom of investigating, of pushing technology forward. European programs are fine, ERCs, basic research. And here I would say, try to be a bit alone. Researchers may imagine, think, and invent. Second thing, create an ecosystem. If you really want to push these inventions to the market and change regulation, you need an ecosystem. So work with the others in order to make the movement, not only alone. I think that the basis is fine, but you need an amplificator somehow. And here I could explain you 2 main things, which are considered very relevant. At IREC, when I joined a few years ago and I moved to technology transfer, we created 2 instruments, which are part of the system. First of all, we created a network of researchers. It's called Energy for Society. And the objective is not doing research. They do it already by themselves. The thing is, we train them, we help them, and we boost their research in order to be transferred to technology. And this is a few years ago, it was not the case. Now it's much more common, but still, PhDs, postdocs need to be trained and aware of that. And that's crucial. And second, we have created a community of energy, let's say R&D plus I stakeholders. So research centers, universities, companies, and associations. To do what? To create R&D plus I, to generate an ecosystem where these projects on low carbon technologies, energy efficiency, smart grids, that may require innovation and regulation, prove things. So demo pilots, bring technology to real life. And at that, we reach the level or the limit of the regulation, what the regulation is helping, and in which respects regulation is blocking the innovations. when you have the best knowledge, you have the best ecosystem, then you need the tools. And again, you need facilities. The public investment and the public-private partnerships may deblock that. And I give you another example, which goes on the 3 blocks I just mentioned. We have created a technology platform, a physical technology platform. It's 3,000 square meters, being built today in an area close to Barcelona city. It's a bit out of the metropolitan area, in order to be a test bed for companies and researchers to test technology, to really bring this technology further. And in addition, this test bed will be certified as a sandbox. Why? Because we need a playground where to test these things. One thing is very nice to test our technology in our lab. Fine, it's a controlled environment, but we need real environments. And for that, it's not only just putting that on the streets of Barcelona or on the streets of any other city. We need a flexible place where to test these technologies. And we have conceived that with the administration. Administration is paying that. IREC is promoting that and managing, but companies are involved. And the idea is to involve as well administration to do a sandbox and focus not on the technologies themselves, but focus on the energy system integration, how the systems can be integrated from the building, from the end user up to the network, how we can combine gas, electricity, and thermal networks so that we can enable these technologies to be validated and tested so that they can be deployed on the market later on. So the best research, create ecosystem and for partners, and then create tools. And all of that public-private partnerships. So the best public money is the smartest one invested and focused on tools to bring new technologies to market. And that's what we believe. I will stop here and I will leave other things and ideas for the debate a bit later. Thanks.
Thank you, Manel. Thank you, Manel. Collaboration, cooperation, and public and private partnership. Well, it's the turn of Andreas. Please, Andreas. Yes?
Okay. Now, is it okay?
Yeah. Please proceed.
Okay.
Thank you.
Okay, I'm sorry for that. Okay, thank you first being invited here, and thank you, Andres, to introduce myself. So I'm Andreas Sumper. I'm part of the CIRCE research group at the UPC, Universidad Politécnica de Catalunya, and today I have prepared some slides to quickly show you a little bit more about what we are doing. And here I would like to give you some example how we try to jump this barrier of like what we have in between of research and the implication of the transfer of the results to the market. So, well, for that, can you please move the slide? Next slide, please. Okay, I want to just quickly introduce myself here. I'm professor and part of the research group CIRCE UPC, and here we have basically 3 lines, which is the enertronics, which deals with powertronics and applied systems. Then we have the electric power conversion and AC/DC grids, and we have also a mechatronic department, which is dealing with movement of machines. So we are 60 people in total, and with a lot of professors and engineers, but we are basically applied to research and technology transfer here. So we have a lot of customers, not only administration. A lot of companies are having trust in us. We have 10 patents, over 600 conference papers, 400 journal papers, and also a spin-off. Please, next slide, please. So what I wanted to tell you here is a little bit about the gap we have here between normally what we have the research projects. Research projects are typically funded by like in European Union or ET, the Spanish or Catalan government. So what we are having here is basically then excellent research, as Manel told already. So in this excellent research is mostly not finding the way to the market. Why it's not finding a way to market? Because we try to like the outcome focused of the research project is try to this outcome has like tangible results, but it is we need to measure it in different actions like papers, production of prototypes, etc. So how we can jump the gap what we have between these research projects to the market is through several actions. One important issue is to guarantee the tech transfer. Tech transfer, it means that when we are doing or proposing a research project, we have already in mind a product, what we have, what we want to produce after the research. We have in every EU project, we have some tangible outputs at the product. We are not a company. We cannot put it in the market, but we are offering companies to do that. So, and that is our tech transfer part, which sometimes it's resulting in a startup. One important issue is, and that we can find in all projects, that is we need more to be implied in regulation, in the regulation process of the European Commission, but also in the regulation process of the national regulations here. Well, standardization is also important. All research projects can like bring up new standards and new development of new standards in order to standardize the products that we are develop and so lay a ground for the market implication. Well, then we have some issues that were university related. For sure, training is very important. If we skill the people through the project, with the project, we can have like the new future generation, which is able to use the technology we are developing. The dissemination for sure as a university, and for sure patent making in order to guarantee the technology transfer. Next slide, please. So, and well, we are now I would like to just quickly present you an example how we do this in a European project here. This is a project, it's called FEVER, it's about flexible energy production, demand and storage based virtual power plants for electricity market and resilient DC operation. Here CCA has a role to developing algorithms for wide-to-grid charger, voltage control applications, islanding power management application, power quality services, global energy management systems, and the integration into a flexibility market. We are 14 partners from a lot of different countries, so I won't go into detail. So can you please move to the next slide? So, and within this project, we were analyzing what are the regulatory barriers for implementation of such application, and which is focusing on the flexibility. Well, and we made here, this is coming from a former project, we made a analysis of the stakeholder view, where we found out that most of the stakeholders in the electricity sector see that there's a general agreement about that there's a need for solutions for manage the grid actively, and there's a lot of investment that will happen in the medium voltage level, which is very important. Yeah, but here what we have now is a very capital expenditure-friendly regulation, and this is opposed to the OPEX operation, friendly operation, which is then a significant barrier for investment in such kind of solutions, which we will deal later with this point. So it's commonly known that flexibility services are very effective to manage the grid. It is expected one of the solutions, which is the battery solution, that it will become very lucrative in the next 2 to 5 years. Reactive power management is a relevant issue, which is what we are doing in the FIBER project. And well, as pointed out Manel before, it is very important to have business models in mind if you're dealing with new technology, but there's no really common agreement about how this business model should look like. So can you go to the next slide? So coming up, having in mind this like stakeholder view, we're performing research, and we focus basically first in analyzing the European regulation, which is the held in the clean energy package, which is represented by the E-directive and the E-regulation, and well, both they see the flexibility markets as vital to become as a key element, and there will be new agents and new technology in the present in the energy sector. What important issue here is that the distribution system operator should not own and develop or manage or operate this energy storage facility, which is a little bit contradictory with which was the stakeholder view has, and there will in this package they specify specific network codes for those energy storage and aggregation. So that is very, very important. So what regulation outcome, or based on this, we have worked on our own view here, and we can say that, well, the flexibility in distribution networks should be procured from provider. They should be procured from service provider in a transparent and non-discriminatory and market-based procedure. So we should establish like a flexibility market-based procedure, which could be as a market as itself, as we are developing in this project a peer-to-peer market on that. However, also bilateral mechanisms could be applied. Well, the main issue here is how all those assets, as you have seen also in the national plans, there will be in the next years to 2030, like 20 gigawatts on storage being implemented in Spain as a plan. So how can all these storage devices be integrated in those market-based procedures? And a very important conclusion that we have is we need to change our regulation. We are having a very capex focused regulation, and we need to, in order to recognize the costs of the flexibility procurement, we need to switch to at least to a mixed capex plus opex regulation in order to recognize that costs. So, in a nutshell, that were the conclusions we had in this FIBRE project, and I hope this conclusion serve like an example how we are using like research projects like this in order to transfer the regulatory needs to the authorities, where those issues or these conclusions we are like exposing in the bridge initiatives and in different initiatives in the European level. So thank you very much. That is all from my side. So for any question, for sure, I'll be there for the discussion.
Thank you very much, Andrea, for presenting the results and conclusions of the FIBRE project. So at this moment, Damien, please, can you present your ideas?
Yes.
Thank you.
Yes. Thank you, Andreas. And first, I would like to thank for inviting me to this workshop together with other very well-known research centers from Spain. So, as Andreas said, I work for CEA in France for more than 10 years now. And before that, I worked during about 10 years for big companies in industry of batteries and automotive industries. I would like first to present 3 short slides about CEA for those who don't know our research center. So please, next slide. Okay, so these are the key figures that from 2019. We are about more than 20,000 employees with a budget of 5 billion euros per year. We have much patents, about 7,000. And some publications also. So these figures are for global CEA company, which includes, let's say, 4 big parts. The first one is for defense and security, so strategic independence of France. The other one is for nuclear energy. We have also a department of fundamental research, so very close to other academic research centers. And the one I'm representing today and the one which we are focusing today is CEA Tech, which is dedicated to technological research. So the aim of CEA Tech is really competitiveness of French companies. Okay. So in the next slide, I will make a kind of a zoom about CEA Tech to give you some more figures, because these figures are really dedicated to, let's say, technological transfer in many fields that I will not detail today because I don't have the time to do that. But we are around 4,500 people, the budget, and many industrial partners. We we are let's say about 8 years ago, we were located in two main areas. One was in next to Paris, in Saclay, where there was the LIST, the first department, and the other area was near Grenoble with the Lytton and the Leti. And for more than 7 years now, we have spread out in different French regions, like in Toulouse, where I'm located. So we are present in many technological fields, from nanotechnologies, nanoelectronics, to almost any field of energy transition. Okay, and as far as I'm concerned, I'm responsible for a platform in Toulouse, which is dedicated for energy transition technologies, which is called Totem. I will not present Totem today because I don't have time, and this is not the objective of the workshop. Next slide, please. Okay, so now concerning the energy in CEATEC, it is, let's say, we have a research center named called LITEN, which is dedicated to new energy transition and new energy technologies, with the figures that you can read. And the main fields we are working on are everything concerning solar and grids in Chambéry, electromobility, both batteries and hydrogen, many also subjects regarding advanced materials, which is for us a transverse subject. And the last one is concerning biomass, thermal engineering, and hydrogen. Okay, so this is it for CER presentation. Now on next slide, I'm just giving you a few words about the CEATEC innovation strategy, because it's important to know what is the difference between what we are doing in the field of technological innovation compared with our colleagues from many other research centers. So of course, like everyone around the table today, we are working to do innovation. Our field of research is for technology readiness levels between 3 and 7. So we really are innovation catalyst and accelerator for businesses. Okay. Industry, this is a key point on CEATEC, because we target many kind of industries and of all types, all size, and the way we do that is mainly with patents more than with publications. And the way we are doing this is by transferring technologies and having a licensing model, which allows us to really help companies being more competitive. The third point is regarding the platforms, which is a very important point, because at CEATEC, when we talk about platforms, we talk about installations that are really international caliber, and it is really for being used by our industrial partners. So it is, let's say, one of the relevant point, which is mostly different from any other academic research center. And the last point is our experience, which is let's say, result-oriented culture, okay, and really a long-time cooperation with industrial partners and research centers, other research centers. Okay, next slide. The topics for this workshop was about open innovation, and I would like just to give you a specific example of what we are doing in CEVA regarding open innovation. Last year, beginning of last year, we opened what is called Y-Spot, which is the first CEA Open and Collaborative Innovation Center. It has cost 17 million euros, so it's quite a big installation. And let's say it's you can see some pictures on the screen. So today it's existing. We have deep tech inside because in total it's more than 3,000 meters square dedicated to technological innovation, and it's very different from other technological platforms that we have in CEVA. This Y-Spot center, so this Open Innovation Center, has modular spaces to accommodate companies in technological residence. We have a rapid prototyping workshop to test a concept in the real world, like Manel said just before, in a real environment. We have a showroom of many innovations. We have hundreds of different innovations presented in this showroom, and showcasing the know-how of the CEVA and, of course, of our partners also. And we have a place also for events, conferences, exchanges to promote new ways of making innovation. And also, as this Open Innovation Center is located directly in our R&D center of Grenoble, we have a direct connection with the CEVA R&D equipment and laboratories. Okay, so it is to give you a very explicit example of what we are doing for open innovation. And if I had to sum up, I would say that our ambition is to go from a concept to a pre-industrial solution within 18 months. So the aim is really to manage to compact the innovation cycle by imaging, planning, exploring, designing, manufacturing, evaluating, and developing at each stage of the innovation cycle to let's say, to speed up this cycle. Next slide. I try not to be too long, but this is the last one, and there is much text, but I'll try to explain what I wanted to say with this slide. One of the questions of this workshop was also the role of regulation in the promotion of disruptive projects in energy sectors. And regarding the energy sector, I wanted to speak about one specific subject, which is hydrogen. I think all of you is aware that hydrogen is really a key point in the energy transition everywhere in the world, and specifically in Europe and in France, in Occitanie. We have a very good dynamic around this hydrogen subject. Here I've put some points of the national French strategy for the development of low carbon hydrogen in France. And okay, these different points I let you read, but there are also some examples of new uses of hydrogen in the energy networks, in industry, in the heavy mobility or tomorrow, and also in the H2 infrastructures. Okay, so regarding this subject of hydrogen, we have in Cevatec many projects, many startups related to that. We have very interesting technologies, disruptive technologies of electrolyzers in order to increase the efficiency of electrolysis. But what I wanted to say in this workshop to open the debate is that I think regulation can help developing these innovative technologies, but in the other way, I think that innovative technologies can help also promoting new regulations. And hydrogen is a good example to illustrate this, because it's, although the technologies of hydrogen are not new, because it's well known since more than a century. Today, the difference is that it's becoming industrially feasible. So it means we really think that we can make it with hydrogen in different fields, mobility, industry, energy networks, and so on. So, and the problem is that the regulation is not ready for this for the moment. And I think that in Technology Research Center, we shouldn't wait for the regulation to be ready, but instead we should push it and boost it in order to make the regulation be ready for the new technologies, the new services around this hydrogen subject. And this is my conclusion for this presentation. Thank you.
Thank you very much, Damien. Thank you very much, all of you, for these interesting thoughts. We have time only for one question. I have simplified the model of the problems due to the regulation in two big groups: the lack of regulation and the excess of regulation. Let me give you some examples. The lack of regulation, the excess of regulation, it is better. It is easier to begin. Doesn't allow you to prove the different things you want to push on the market. Okay, but the lack of regulation makes uncertainty, because, for example, it is not regulated how to measure the efficiency of a new energy or so on. So this uncertainty in the market is seen like a problem, because if you don't have a clear business model, it is impossible to go to the market. For each of you, which of both is more important? I don't know if you, just to give some order, you can follow the same order that you have had in the previous speeches. So please, Manuel.
Thank you very much. Yeah, very nice question and very tricky one.
Yeah.
I may agree on what my colleagues have said, because they said very nice things, and actually I liked very much the last one, and I will pick up on that. Don't wait for the regulation, just push it forward. So if I take these words, which I love actually, doesn't matter if it's an excess or lack, right? Because you need to change it anyway. You need to push it forward. You need to prove that things may change, either adding new regulation or changing it and avoiding part of it. Andreas mentioned the flexibility. Flexibility markets are being opened in Spain today, and there is plenty of regulation, but it's kind of a undefined wall. So I could say that the most common today maybe it's lack of, because we don't know, and that's the playground where it's a bit more, I could say, easy. So going against something is always difficult. Creating things, it's easier. So I would turn it a bit the other way around. research may find the gap of the regulation so that you can prove new things and propose new things that may jeopardize the others. But you need to look for the gap. So I will build up on my two colleagues' sessions or comments. Don't wait for it, find the gap, and for example, in flexibility, push it forward. You are not going against anything, just invent new things.
Yeah. Well, very good answer. Thank you very much. Andreas, do you have something to add?
Yeah, well, thank you. Really good answer. And I will want to bring here in something new or a little bit a different viewpoint, because sometimes what we want to do is to, we have some regulation. It could be like horses, and we try to use the regulation about horses to apply to cars like 100 years ago. The point is the technology is moving so fast forward that the regulation is so much behind. We want to regulate new things with rules of like 20 years ago. And that is the main issue here, basically, because we're the speed of our technology development is much faster than regulation speed is, and this is very, very, very complicated in order to deal with. So that's why sometimes there's a lack of regulation because there is new ground to explore it, and sometimes excess to regulation because of a lot of things that are outphased, but they are still valid, and so you have to accomplish with that. So, and that is really the difficulty here. So what we need is to speed up our regulation processes, to create sandboxes, to create really playgrounds where we can figure out things, and to introduce some flexibility. But we don't have to forget that regulation is also very necessary because it protects consumers. So we have to find this balance.
Thank you very much, Andrea. Damien, you have the most difficult part. That is adding something to this very good answer.
Yeah, very interesting question, and I agree with my two colleagues, of course. What I could add is that for me, regulation shouldn't be the problem. It is, but it shouldn't be. It's like lawyers, in our companies. When, as far as I'm concerned, when I'm trying to make a partnership with companies, I have to make the contract and to make it validated by the lawyers. And this is our internal regulation. We have some rules and so on. But as I used to say, they are to help us, not to make it more difficult. And this is really a collaborative work because they are necessary. They are there to make it let's say contract to protect us, to protect our partner, and so on. So it's very useful. But when it comes to be too complicated or too difficult to understand and to read, then it becomes a problem. And for me, this is the same for regulation, for research centers and innovation. The example of the hydrogen is quite good because, as Andreas said, it's like for the horses and the cars. When I begin to enter the world of hydrogen about 7-8 years ago, all the standards and all the regulation was, let's say, not adapted at all. So when we wanted to create a new hydrogen vehicle or a new hydrogen installation, there were no standards, no regulation on which we could, let's say, that we could use. But the CEA then decided to really write them together with the people of AFNOR and so on. So as Manel said, we didn't wait. We pushed our regulators at the politic level in order to read regulations and standards in order to support our innovations and our technologies. So I really think it's not, let's say, sometimes it's a lack of regulation, sometimes it's in excess, but at the end, the answer is, of course, in between, but the key point is not in the regulation. It's once you have your innovation, whatever it is, technological or services, I think that we should be able to make the regulation adapted to that innovation.
Thank you. So thank you very much to all of you. I think that one possible conclusion of all of this is that one result of any innovation process must be the regulation framework in which this innovation can be deployed properly. So thank you. And I hope that all these conclusions, all these ideas have been useful for all the audience.
Thank you.
Thank you, Andres, Manel, Andreas, and Damien, for sharing with us your vision about the innovation and the relevance of the regulatory framework. I think that it has been very interesting points, different approaches with, let me say, a common view. Achieving climate change objectives requires the removal of different barriers and with new tools. It has been pointed out the relevance of energy regulatory sandboxes, the relevance of open innovation centers, just to test and validate new energy solutions and new business models, perhaps in the most relevant aspect, in a real environment. And that will not be fulfilled without the contribution of research institutions, but also the private sector. And that is the second round table with companies that they have a different presence in the value chain of the energy sector, but with also a common approach. The transition for them is imposing immense challenges but also is creating tremendous opportunities for firms willing to act quickly. A successful energy transition undoubtedly means building momentum in renewable energies such as solar, wind, green hydrogen, and the rest of renewable gases, or other low-carbon solutions. Also, it's relevant to create new solutions, and this is required, this innovation process. To talk about this business sector, today we have with us three relevant standing companies in the Sudwest region, such as EDP, Enagas, and Elewit. For me, it's a pleasure to be in this round table with them, and it will be really interesting to have their vision about the situation of the innovation and the relevance of the regulatory framework when they are just fostering innovation in the different energy fields. The first speaker is Yolanda Fernandez Montes. Yolanda is Director of Environment, Sustainability, Innovation, and Climate Change at EDP. Thank you, Yolanda, for joining this seminar, for being with us in this seminar. And the floor is yours for this first presentation of your vision about the situation of the innovation and the relevance of the regulation when trying to foster the different initiatives in the company. Thank you.
Okay, Hello, everyone, and thank you very much, Joan, for this invitation, Funseam. I would like to share with you seven insights that could be seen as barriers for innovation, one question and two final remarks. And starting with the first of the insights, I would talk about the innovation not only just as about technology. Innovation must be approached with a broad vision, including activities not necessarily related to technological innovation, because innovation activities should include both those that have a technological component and those that refer to process or business innovation. The evolution of the organizations and the new scenarios we're facing make necessary to stimulate investment in critical issues that go beyond overcoming technological challenges. Innovative solutions will need to be applied in the social, environmental, and organizational domains. An improvement made in a product, in the development of a new one, or in the business processes of an organization is an innovation, as long as it differs significantly from the previous products or processes that we use in the company. The second trend or barrier that we could see is related to the steady demand for short-term results. The demand for short-term results reflects a lack of understanding of the complex process of technological maturation from idea to materialization into a new product or process. The scientific method of trial and error is very laborious and time-consuming. Some innovative products are the result of a long process of testing. Just for giving an example, the lubricant WD-40 owes its name to the expression water displacement 14th formula. It was not until the 14th formula was tested that the development cycle was successfully completed. Another thing that we could mention as a barrier is that related with the strong focus on the commercial stage. It's also common in the business world to concentrate innovation efforts on the final stage of the technological maturation process, the production of new products, to forget innovation that takes place throughout the value chain and which allows companies to acquire competitive advantages in terms of cost reduction. For a fifth idea, I could talk about fourth idea, I would talk about the challenge of technology transfer. We've already had this previous roundtable discussing how to make a technological transfer effective. From our point of view, one of the obstacles to technological transfer is the different mentality between scientists and entrepreneurs. Scientists seek knowledge of the unknown, driven by curiosity, while the business world seeks to create value for the shareholders and the customer. These two very different mental models make communication between the two worlds difficult. This explains why major innovative companies such as Sony or Microsoft were founded by two people, with one providing the scientific technical knowledge and the other the commercial vision. The two worlds need to talk to each other, and innovation brokers are needed to understand the motivation of these two worlds and connect them. The fifth barrier is referred to the entry barriers. Some business sectors, and perhaps energy is one of them, have been successful in creating barriers to entry by translating the technological specificity of their business into the regulatory environment. Innovating in the sectors means facing a complex regulatory structure, and in societies strongly designed to guarantee rights and avoid risks, such as those in Europe, this translates into difficulties for prototypes in real demonstration environments to obtain the necessary authorizations. Pilot and demonstration projects deserve specific and streamlined permitting processes that will help the startups to quickly test their solutions to the market and improve in their acceleration and competitive process. For the startups, time is money, so supporting them with the streamlined permitting would be even more effective and smarter than providing them with financial support. So it will be highly beneficial and innovative to have a common European fast pass permit to quickly deploy demo projects. And talking about startups, we will come to the sixth difficulty, or something that happens very often, and it's the danger of tailor-made solutions. It's common for corporates to develop programs to attract startups, and one of the mistakes that corporates make is to ask startups to solve customized problems for them. This effort takes startups away from their technological development roadmap and prevents them from properly scaling the products. The temptation is very high as startups do not have sufficient resources and companies are very big usually for them. And finally, we come to the seventh barrier or difficulty that comes up when there is a mistrust of venture capital entities towards corporations. We are facing it's common for corporates to develop venture capital instruments to participate in the capital of the startups they want to help. Some venture capital funds are wary of the role of corporation because they believe that the presence of a corporation in the startup's equity may discourage the corporation competitors from being the startup's customers. This distrust is an obstacle to effective cooperation between players. One more. And then we come to the question, are we ready for the digitization? We make this question very often to ourselves because both digitization and the use of data play a decisive role in innovation in the first quarter of the 21st century. Digital tools are now ubiquitous and even the simplest process are now required digital skills. But in fact, the proportion of the population that knows how to code is very small. And in the data-driven economy, too few people have the basic statistical skills to be able to interpret data correctly without being biased. A stronger effort in education must be done not only within the companies, but also in the society from early educational stages to ensure efficient and widespread digitization. And going to the final remarks, the first one for us will be an accurate measure of innovation. As innovation has become increasingly important in economic and social development, the need for metrics to guide public policy in this area has grown. However, despite efforts to update and improve these metrics, many companies still find it difficult to identify and measure their innovation activities, which leads to a gap between the data collected in official statistics and the actual innovative activity of the business community. Last year, we led a working group at Ecotech with other companies, innovation agents, local governments, to propose solutions. We concluded that Spanish institutions could report better innovation effort figures. I invite you to read the report and think about the necessary changes in your organizations. You have there on the slide the URL of the report. And the last one, I would like to end with a positive approach. From our point of view, there are not as many barriers as we think. The belief that there are barriers to innovation can be modified if we adopt a broader mental model to consider innovation. In fact, it may be that in addition to barriers to innovation, there are also beliefs that prevent us from thinking innovatively. And not only think, but we must also act innovative. That's why EDP names this decade as the decade of action, because it's the moment to put ideas in place. And well, that's are the main ideas. If you have any other question, we can speak later. Thank you.
Thank you, Yolanda, especially for these insights about the innovation and the innovation challenges. And I think that perhaps the most relevant message is the last one, the decade of action and the relevance of innovation with a more broader mental model in order to adapt the regulatory framework to the challenge associated with the energy transition. Now we are moving to the second speaker. Second speaker is Anton Martinez, that is the Renewable Gases and Services Director of Enagas. As you know, the TSO and the transmission system operator of Spain. Anton, thank you for joining this seminar, and the floor is yours.
Okay, thanks, Joan, for the introduction, and thanks to Funseam to inviting us to join this interesting roundtable. Okay, I would like to share with you what Enagas is doing in the field of hydrogen and why and how the regulatory barriers and the legal loopholes are impacting our new activity. Enagas, as Joan has mentioned, is a midstream company. We are managing natural gas assets both in Spain and in 8 different countries, in which is a well-established business with a track record of more than 50 years. But we are also developing new activities in the field of the renewable gases, both in hydrogen and in biomethane. Why? Because for 3 main different reasons. Because we are a company committed with the decarbonization process, because we believe that it is a very good business opportunity in these fields, because decarbonization is not the same that electrification, and other energy vectors are going to be needed in this decarbonization process. And also, we strongly believe that these new energy vectors, both hydrogen and biomethane, are going to use part of the existing natural gas infrastructures. That is mean that the natural gas infrastructures are going to have a longer life a part of the natural gas, and are going to be a key essential asset to the decarbonization process. With this idea, Enagas started to develop a portfolio of projects 2018, where probably green hydrogen was not so popular like it is today, following 5 criteria. First one, project that could contribute to the decarbonization process, have a tractor effect through the value chain, contribute to the development of the Spanish industry, create sustainable employment, and develop this project with partners. With these 5 criteria, we create a portfolio of projects with the idea of pushing forward these 2 energy vectors, green hydrogen and biomethane. We develop a portfolio of projects in which, with, I would say, 4 different types. The first type of project are pure R&D projects. We are developing proprietary technology to produce hydrogen with photoelectric catalysis. It's a project that we are developed jointly with Repsol. We have some demonstrative projects at industrial scale that are the first project we are deploying in the hydrogen field, and then we are designing and developing all other large-scale projects that are more linked probably to the scaling up of the hydrogen as an energy vector. But I want to focus the thoughts and the discussion about the 2 first kind of projects, the technology, the pure R&D projects, and the first demo project we have under construction. This is the idea of the future hydrogen transport system that we jointly defined with other European TSOs, and we believe that it's going to be play a big role in the decarbonization process. But I want to focus my ideas about in what the companies like Enagas, that are companies that their main objective is to develop infrastructure, I would say scale projects, are finding when they want to move their technology from the R&D laboratory to the real scale. We have projects, around 30 projects all around Spain with more than 50 partners, targeting all the future uses of the hydrogen, both in mobility, replacing green hydrogen, thermal uses in hard to abate sectors, and renewable energy management. But what we believe that hydrogen is going to be key for this decarbonization process probably is well known for all of us, because they can play, I would say, in different roles and can link between different sectors. And a lot of companies that are involved in the energy process and in the decarbonization are pushing this kind of project. But what do we found when we want to scale up this process and these projects? We found that the legal and regulatory framework is not adapted, it's not prepared to deal with this authorization process. As far as we are talking about R&D projects, and we are talking about developing pilots or laboratory scale projects, moving TRL 6 to TRL 8, TRL 8 to TRL 9, probably Spain has, most of European countries has clear rules about how to move all these steps. But what happened with these first projects want to go to a real pilot in which we have to interact with the local authorities to ask for permittings. There is not a clear framework in which the authorities can grant that permitting, because most of the local authorities find themselves that are the first time that they need to deal with this kind of authorizations. Generally speaking, all these barriers have several impact in the cost competitiveness, because it means that we need more time to get the permitting, we need more, I would say, effort to develop all the legal aspects, and it has a clear impact in the time to market and in the competitiveness of the final product. But to have an understanding of what does this mean, we are going to share a real example. Is the Green Highland project. Is the project we are developing in Mallorca, jointly with Acciona, Cemex, IDAE, and Redexis. It's a project that was granted with a 10 million euros subsidy for the European Union 2 years ago. And we moved from a conceptual idea to a basic engineering, detailed engineering, and a construction phase, in which we need to go to all the authorization process of an industrial scale project. What have we found? That, for instance, to get an environmental impact assessment permitted, we need to ask for an environmental assessment of the process. The process is a hydrogen production processes. With electrolysis, yes. But in the today regulation, there is no difference between producing green hydrogen or gray hydrogen. As there is not a clear difference in the authorization process, the authorities follow the more strict process. That it means that to get the environmental impact assessment, you need to pass all the permitting process as it was a steam methane reform, being a water electrolysis plant. And that means more time to get the environmental impact assessment permit. This is clearly identified in the roadmap of the hydrogen, in the Spanish hydrogen roadmap, but they need change in the environmental impact assessment law that need to be approved in the parliament. What this means? That we need to review all these pieces of regulation, I would say a legal framework that impact the real deployment of the hydrogen projects. This is only an example, but generally speaking, we need to think about that. Once we bet for a sector, one we believe that we need to scale up a new sector or a new energy vector, we need to identify what are these barriers, but not only identifying and say that it's going to be changed. We need to have a clear roadmap about what needs to be changing, which I would say, a local authority or a national government need to change what and have a clear roadmap of what is going to be changed in the next years in order to facilitate the implementation of these kind of projects. And this is a clear example about how a real regulatory barrier impact a real project that is today under construction. Okay, thanks very much.
Thank you, Anton, for your presentation. Introducing a new element, another barrier, such as the permitting process of such innovative projects. Last but not least, we have Jose Carlos from ELEWIT. ELEWIT is the technological platform of the TSO, Red Eléctrica de España, and also with a company that is fostering innovation through connectivity and digitalization projects. Jose Carlos, please, the floor is yours. Thank you.
Thank you. Thank you very much. Thank you, John. Thank you, Funseam, and the whole TransNet project for giving us this opportunity to share our views. It's really a pleasure to be here on behalf of the Red Eléctrica Group and ELEWIT. ELEWIT is, as you said, the technology platform of the group, and we push the innovation of the group, of course, collaborating with the innovation ecosystem in two critical sectors for our century, which are the energy and the telecommunications. So we want to contribute to the energy transition and the development of the telecommunications on the basis of technology and innovation. And innovation and regulation must go hand in hand in so highly regulated sectors such as the energy sector and also the telecommunication sectors. So that's why I believe that this event really makes sense. It really makes sense to stop and think about this relationship between the innovation and regulation. And why I do believe that innovation and regulation must go hand in hand? Well, because in the end, energy transition is just a journey from the present to a decarbonized future. And for that journey, we only have two tools: innovation and rules. If you allow me the example, it's a journey in which the whole society is in the same car, which is our current energy sector, and we are all driving towards a decarbonized future. And with that car, and with the driving regulations that we have in place, we already know that we won't get to the final destination. We need to change things, and we can change the car, and we can change the driving regulations. And the point is, we need both. And why? Well, because if I'm testing a prototype of a flying car, for example, or a car with functionalities that allow me to drive faster but safer, what I need is that the regulation allows me to test the car so that we can safely fail, we can safely learn. Maybe not in the main road, maybe in a separated unpaved road with no cars, no pedestrians, but I need that test environment to be allowed by the current regulation, at least for some time. So I need a temporarily ad hoc help from the regulation. And then in the case of success, if I actually have a flying car, we need this that regulation is eventually structurally modified so that we can drive our nice flight car. We need new rules for that. We need new rules for a flying car that we don't have until we just develop that technology. So getting back to the reality, our view is for this temporary regulation to facilitate the innovation. It is necessary to start up as soon as possible with the regulatory sandboxes. I'm referring to Spain, but this is something that is already contemplated in other countries, and we, in Spain especially, we need to learn from this experience. In September 2021, there was a public consultation on the draft Royal Decree on Regulatory Innovation. We believe that this is the good way to move forward, and we hope that these regulatory sandboxes are set up as soon as possible. And how do we understand that sandboxes should look like? Well, a regulatory sandbox should temporarily eliminate the disincentives to innovation that are inherent to the application of the general regulatory framework to an innovation project. Let's face it, the current regulatory frameworks are not prepared for new technology developments. So in these regulatory frameworks, temporary regulatory frameworks of sandboxes, there are three main topics which I would like to address and that we believe need to be eliminated, or let's say adjusted temporarily in these regulatory sandboxes. So the first one would be the cross-activity or cross-sector limitations. So there shouldn't be limitations to carry out cross-cutting projects. I mean, joint projects we are a regulated company, as you all know, in terms of TSO activities, but we are eager to participate with other companies of the energy sector, and also, why not, of outside the energy sector, in exploring new technology developments, new possibility. As you know, well, we have energy and telecommunications activities within the group. We are exploring, for example, the use of transmission assets as a basis for providing connectivity bubbles of 5G technology, using also or leveraging also on satellite telecommunications. So there is a good opportunity to mix sectors, and the current regulations are not necessarily prepared for that. And that should be one point that could be addressed in these regulatory sandboxes. And then another cross sector topic is the impact of side regulations outside the energy sector on the energy sector. So I'm referring maybe again to telecommunications, but we are, for example, we are exploring the use of drones to carry out and to automate some of our activities. And in that regard, we don't deal with electricity regulations only, but we deal with air navigation rules, for example. So we need to look also at those side regulations that have an impact on the regulation within the sector. Then the second point is to address some risk imbalances in the innovation in the regulatory framework when we refer to innovation projects. So the assumption by the regulated company of the entire high risk of innovation projects should be addressed. Maybe progress should be made in the specific remuneration treatment of these projects so that risk sharing schemes are implemented. If there is no such risk sharing schemes, the incentives for regulated companies to carry out these activities is very low. And finally, and this is something that has been addressed in the previous table, I would refer to regulatory gaps. Of course, the regulation is prepared for the technology that we have now, not the technology that we have or we will have tomorrow. So it's very likely that there appears an absence of regulation applicable to the innovations that we have. So the sandbox should provide the minimum regulation necessary to carry out these projects with the necessary legal certainty. So I'm sure that there is no regulation for a flying car, but we should address something temporary so that we can test that car. And then after these temporary regulatory schemes of the regulation of the regulatory sandboxes, then what? Well, the point is, after this transitional period, the learning achieved with the pilot project must be internalized in the design of a new regulation, which should provide the companies with adequate incentives for innovation in the future by withholding part of the benefits achieved and sharing those benefits. So again, it's a matter of addressing benefit sharing schemes and also share the benefits of the innovation with the system. So in summary, the point of my presentation is that for me, this is not a chicken and egg problem. In what's first, innovation, regulation, which you must innovate first and then adapt the regulation, or the other way around. Well, this is not a chicken and egg problem in my view. So both are the egg and the chicken. Both must evolve. Both must grow together. So regulation and innovation must go hand in hand. And for that, temporary regulations are needed to foster innovations and the development of new technologies. And then here I'm referring in terms of regulation to the regulatory sandboxes as a proper and fair tool to foster that innovation when the technology must be developed. And then once that technology has been tested, then long-term regulations should be adapted, because in the long term the regulation should be flexible enough to foster that innovation in the long term, and then to foster the actual introduction of those technologies that have been developed as a consequence of or with the help of regulatory sandboxes. So that's all from my side and my point in this table. Thank you very much.
Thank you for your intervention, and especially for the reference to the energy regulatory sandboxes, a tool that has been discussed in the different roundtables. And let me say that inside the project, this European project, where we are promoting different living labs models in the university fields, the introduction of energy regulatory sandboxes is one of the key aspects in the process, because we consider that, as has been pointed out in the previous roundtable, that the speed of the technology requires some new tools in order to adapt faster the regulation. And we have just few minutes before the last presentation, but let me ask a question that for us is extremely relevant. We are talking in general terms of energy regulatory sandboxes, but I don't know if you identify some specific fields of innovation where the energy regulatory sandboxes could be more helpful in order to provide this new speed in the regulatory framework in order to adapt this regulation to the innovation process. I don't know if...
Yes, if you want, I can start. Probably, Joan, in our view, the regulatory framework needs to be focused in these energy sectors in which there is not a clear track record of, I would say, scale projects to be delivered. What this means, for instance, in hydrogen is a clear example. When everyone's talk about green hydrogen is in the front page of every newspaper, but there is not real green hydrogen projects in Spain. What this means that when you need to, I would say, face how to really scale up a project from a pilot, from a laboratory to the real world, there is not regulation at all. And the problem when there is no regulation in the United States is that you can do everything. In Europe is that you can't do anything. It's the big difference between other countries and European regulatory framework. What this means that probably we need to start for these new energy vectors in which everything needs to be done.
Thank you, Anton. Yolanda, please.
Yeah. No, from my point of view, we have to distinguish between prototypes or pilots with assets, because all the authorization process is a mess. So it's nothing to do with sandboxes, because you will have to put in place your prototype and try and make a trial. So I will make a difference between prototypes and business models. Business models is another thing, because we can try different business models in a sandbox regulatory environment and extract from the experience many interesting issues or topics that we can analyze through the regulatory bodies. But I think that we need to make this distinction between prototypes and business models.
Thank you, Yolanda. And Jose
Just
Carlos, I
to
don't know if you
add-
have something to add.
Yeah, I would add something. Well, I agree with the previous comments. I would just add maybe to underline one of the points of my speech, which is I believe that these cross-sectorial projects are the ones that are more needed of these regulatory sandboxes. Basically, because so far the technologies were very much sector focused, and then we were all used to apply technologies from its own sector, and nowadays what we are seeing is that we can explore technologies from one sector to the other, and this to the others, and this is what the innovation ecosystem brings all as an added value. We can expand the use of technology from one sector to the other and try to get added value from that cooperation. And maybe it's in this regard where the regulatory gap is higher, because the regulations are mostly focused on one single sector, and basically or in general do not take into account the interactions that can appear across sectors. I mentioned one example, which is the use of drones for one of our activities. The main point that is limiting our progress with drones to automate some of our tasks and make them safer is not the technology, but it's the regulation that limits some of the, let's say, of the tasks that we can do. So it's in this touching points between sectors in which I think that regulatory sandboxes are most needed.
Thank you, all of you for your interventions. We don't have more time to discuss and to debate. Let me say with perhaps the most relevant idea. Yolanda, you say that is the decade of action. I think that it's extremely relevant. We require to transform our energy model. Obviously, there are major uncertainties surrounding this process, but the most relevant aspect is to define a solid and resilient policy and a regulatory framework able to provide the solutions to the energy transition. Just to finish this seminar, we have as a keynote speaker, we have Diego Pavia, CEO of 8 InnoEnergy, a leading institution supporting innovation projects and businesses, and also will offer his vision about the energy situation from such a relevant institution in Europe. Diego, thank you for being with us as a keynote speaker in this seminar, and the floor is yours.
Thank you, Johan. Good afternoon, everybody. If I could have my slides on the screen, please. Thank you. So I would like to, for 10-15 minutes, to pitch about our credentials and also the lessons learned that we have captured over the last 11 years that we have been doing innovation in sustainable energy in InnoEnergy. And then what are the things that we are proposing to the Commission and the Member States to improve the landscape for innovation in sustainable energy. So Credentials, who you have in front, is a company that have scrutinized since 2010 5,000 innovative cases. And when I say innovative, it's about the pre-commercial and commercial stage, not the basic research or the applied research. All of them is sustainable energy. We invested in 450 and 150 write-offs, so they did not deliver what they expect to deliver. 300 of them being today strong products that are selling and are being upscale in the market. What we do is three things. We take cases, we de-risk them, and we accelerate them to make them bigger. That's basically what we do for the last 11 years. That's our track record. Then in terms of how we do those things, and Juan Carlos just said a couple of months ago, is all about the ecosystem. We are not a bank, don't look at us as a money. We have created an ecosystem of so many partners, almost 500, with universities, research institutes, industries, investors, regulators, where all the cases find their catch and when they need it to develop within the ecosystem. As you can see, we're in 21 European countries. And if you come to us, basically you are in a micro European energy system to test your things. If we go to some examples of what we have delivered over the last 11 years, then you see here mapped against in the vertical axis on the right side, the objectives that all Europeans have given ourselves in the Fit for 55. Then you see some examples, and already some of them unicorns. Unicorns meaning that first, they are above 1 billion euros of market capitalization. And second, it's very important for us, they are CapEx intensive, because then they draw jobs and industrial development. And the most famous in our portfolio is Norvolt. It's a gigafactory in the north of Sweden, already 11.5 billion euros, 3,000 employees, 50 hectares of industrial site. And the guys that you see in the picture there, they came to us in 2017 with only a PowerPoint. Green steel, also just Anton talked about green hydrogen. So that's another monster that we are supporting in the north of Sweden that will deliver 5 million tons of green steel by reducing the iron with green hydrogen out of the hydropower in North Sweden. Again, that's 65 hectares, and it's like 3,000 also direct jobs. Again, some examples of what we've been doing over the 11 years. Then, like every company should do, we're measuring. And I also listened to the EDP speaker about, hey, we need something to measure the innovation. And this is our dashboard. Our dashboard that every single investment that we do has to contribute to those 9 KPIs, or some of them at least. And of course, the most important ones are the ones on the right column. So the decrease of greenhouse gas emissions, how much the energy costs are reduced, and the deployment of renewables. I will not stand myself there, much more. Beyond purely investing in cases, we were mandated by the Commission to structure 3 industrial value chains. And why is that relevant? Because innovation is not about doing a first of a kind, it's also to replicate what we do across the value chain and in many places, because then you transform the industry. Then you really accelerate the energy transition. So we're mandated by the Commission to drive the Battery Alliance, that is the complete value chain from mining to recycling. We are mandated this February to do the reshoring of the PV value chain, again, from polysilicon to recycling. And we are running with Breakthrough Energy, that is the investment arm of Bill Gates, the Green Hydrogen Acceleration Center. And all of them with one key objective is to develop those industrial value chains that will drive growth and jobs in Europe. Jobs in batteries is like 3 million jobs, new jobs that are required in Europe. In green hydrogen is like 400,000, and in PV is like 500,000 across Europe. So this is what we're for. And the final one is what people say about us. That is third parties. As you can see, they rank us as the top investors in innovation in sustainable energy. Okay, so enough about self-marketing. What are the lessons learned that we have captured along those 11 years? The first one is that the innovation ecosystem, again, innovation, not research, innovation system in Europe is supply-centric, so tool-centric. You see on the left column of the screen, you see all the needs that the innovator requires to make their business case a success. It's about understanding the market, and regulation is very linked to the market, of course. is to drive funds, both dilutive and non-dilutive, is about signing contracts or signing GDAs, joint development agreements, that will become eventually an upscaling industrial site. Is about IP strategy, is about securing that your differentiator is accepted as a non-attackable IP, is about looking at the supply chain. Well, all those needs that you need as an innovator, what normally happens is you, as an innovator, you have to seek them, for some of them in supplier number 1, for some of them in supplier number 2, for some of them in supplier number 3, and so on and so forth. That means that the innovator is not helped in the journey to serve his needs and also along the life cycle. When you are born as an innovator, you are very early stage, so basically you know nothing, and just to look for those support measures, support services, support money, support customers is terribly difficult, because today the system in Europe is pretty much instrument-centric and not innovator-centric. So what we are advocating, and we are showing by example, is from a supply-centric innovation system in Europe to an innovator-centric, where the innovator sits at the center. And the needs are exactly the same as I showed in the previous slide, the same needs, the 9 dimensions that you see there in the graph. And what we do is that we identify, together with the innovator, all the possible supply instruments, companies, off-takers, you name it, in different colors, in different places, in different countries in Europe, that will make their case stronger, sooner, and de-risked. And then what we do is we get a deal with the innovator that in exchange of accelerating the access to those services, in deploying money to them. So our money, we deploy around 100 million euros per year. So that's the capital we deploy. And then we handshake a success warrant-based deal that in case the business case of the innovator will be successful, then we'll get the warrants converted into equity. If the innovator, the case doesn't fly, then we have lost our money. So our logic is also the logic of an investor. And that's the way we believe that the whole European ecosystem should be progressing. And this is the big bubble that you see in my screen is blue. That's the famous ecosystem. All this happen in an ecosystem because it not happens once. It happened in our case 450 times with the 450 cases. And then what you do with this is that all the members of this ecosystem, they find a catch. Because today you're a customer, tomorrow you will be a supplier, today you're an investor, and then you will be harvesting the upside that you have created. Again, is a one-stop shop. That was the first lesson learned, from instrument-centric to innovator-centric. That's the way we should be evolving. That's at least what we're doing. And the second one is that the innovation word, in terms of what does it mean, that is, again, to create something that can be industrialized to create economical value. That's our definition of innovation. It's not about research. It's not about research. In Europe, we are extremely good in the 2 previous phases. So the ones that are creating many times the potential innovations that will become commercial products. And we're using one tool, that is the famous technology readiness level. We believe, and we're experiencing and implementing this, that for the innovation phases, we have to completely change the toolbox. And the toolbox is about the innovation readiness level that is much wider. It's not only about technology, it's about IP, it's about market, it's about consumer behavior, it's about society. So there are many dimensions that should be measured to see the merit of innovative case. And unfortunately, today, the public support service tools do not contemplate this. They only stick to the traditional toolbox that is the TRL. So those 2, then how to progress? 3 more slides towards the future. If we take again what is the research and innovation value chain, and the market, and the market is always the pool. So today what we see is that the support mechanisms that we have, and I just plotted here the ones from Europe, then they're very fit for purpose. So you have in each one of the maturities of research/innovation, then you have the ad hoc support mechanisms. On the left side, pretty much grant-based. Then as you progress, the right side is blended, like the new EIC, the European Innovation Council, that either you will be getting a grant or an equity. And as you progress, then you will be getting to the EIB, that is also giving a good signal to the private banks and the private equity guys that, hey, that innovation is meaningful. Again, here we believe that we are well served. And this is a position where energy today is playing. But then we have something that is extremely relevant, and that is extremely good news because it makes the pie much bigger for all of us. That is the new regulatory framework. As we all know, Europe is recasting all the winter package into the Fit for 55. And it's like 4,000 pages that everybody working in innovation in sustainable energy should be reading. And normally the second part of the package will be concluded this December, and that will be totally the compass, not only for the negotiation with the parliament, but also for the next couple of decades, and I use the word decades, for all of us, or where the money will be, where the demand will be. Then, of course, you have got the ETSs now you have steel, fertilizers, cement, and maritime transport that are becoming ETS sectors, which is good. The national climate plans that have to be adapted to the new objectives of -55. And very important, the green taxonomy. What is this? Is today the number of investments from both public and private, but mainly private, that will go from today brown assets into green assets is $100 trillion. Remember that Spain GDP is 1 billion. So it's a tremendous amount of money that is going to be flagged towards green. That means that when the innovation will be commercial ready and bankable, don't worry, it will fly. It will grow like hell. So this green taxonomy is extremely relevant that also you look at it because it puts the enabling framework for what is very important, that is the demand side money. Okay, so now we go to my last slide, that is, today the 5 proposals for making the innovation system much better for all of us. The first one is what I already mentioned, that the toolbox. The toolbox that we're using today should be enhanced. Good news is that in the new EU innovation area, that the communication will come very soon, in the next couple of months, 3 months, then the toolbox that the Commission will be using, and then the member states, I'm sure they will be following, is much richer. So we're not using the toolbox for research, we are changing or creating a new toolbox that is an evolution of that toolbox for the innovation space. The second is that the skills. An innovator, sorry, but is not a researcher. An innovator is somebody that first works in teams, so we're always talking about innovation teams, not innovators, and is a mix of different profiles. Is the expert in technology, is the expert in markets, is the right manager, so it's always teams. And this is the way we should be thinking. And that's, as Jose Carlos was saying, is about ecosystem, so playing all together. And the last thing that also has been touched a lot is about regulation. Today, when a case comes to us and we paint in colors the regulations in the different European countries, and we see, like in this example, a rainbow of different colors, we do not invest. What an innovator wants is a no market fragmentation. What we want in front of us is a 500 homogeneous customer base, be it B2B or B2C. And that's extremely, extremely relevant, that regulation, not only the sandboxes in the transition, but also the end game, that the regulation is the same no matter which European country. And that will be the strength of Europe if we do. And then traditional measures, that one of them will sound for you familiar, that is the innovative public procurement, innovative public investment. What is this? Is that all the previous phases, research, applied research, is mainly supply side money. You get grants, you develop your technology or your innovation, what happens? What we innovators, we love is customers. And the best customer is the public administration. Because anyway, they're already today costing their energy services and their energy needs. So I just put it there on the right side, just a number. If we took 30% of what administration in Europe every year they procure in energy, that will be 75 billion euros. That is, as you know, equivalent to the whole Horizon Europe. So instead of printing money, we'll just be using the money that today already is being used by all our ministries, all our hospitals, all our schools, all our sometimes publicly owned TSOs. It will be using that for driving a demand, a risk demand, innovative demand that will accelerate the whole thing tremendously. And the last is something that we forget. And our judgment today is that the energy transition, the B2B is working. And I wouldn't say that we'll be ahead of schedule. We'll be delivering ahead of schedule, mainly in terms of transport and industry. Unfortunately, when it comes to buildings, our judgment is a mixed feeling. It's not that positive. And why? Because in the B2C transaction, the C is us, citizens. And the citizens were just observing without understanding the whole energy transition. We don't understand what this means. There's a lot of pedagogy missing. And we needed to spend a lot of pedagogic education to make the citizens understand that the game is together with them, not without them. So those are the 5 things that we're continually preaching in the Commission in Brussels. Some of them are getting traction, mainly number 1, number 2, obviously. Number 4, we hope that this will be much stronger upcoming. And number 5. Number 3, it's, as always, a pain. So thank you, Johan. Back to you in my 15 minutes.
Thank you, Diego. I think that it has been a really excellent presentation, very optimistic about the future of the innovation and the challenges associated with the innovation process. We have just 3-4 minutes, but I think that it's, given your experience, I think that it's not possible to finish without at least 2-3 questions that for us are also relevant. We have been talking about the innovation, the challenges of the innovation, these new visions of the innovative ecosystem. And my question perhaps is more general. Do you think, I think that obviously, especially after the Glasgow COP meeting, the discussion about the role of Europe, which is the relevance of Europe in terms of providing these solutions, that Europe is in a good position to develop this disruptive energy innovation that the transition requires.
Totally.
What?
So on this, Johan, on this, totally. And why? Because when you know that all the big economies, they have done pledges. Pledges is promises. And the pledges basically are changed every time they meet. India, 20 years more. China, okay, give me 10 years more, blah, blah. And this carbon neutrality is very nice, but they are doing pledges. We Europeans, we have voted this March the famous climate law. So we have enshrined this objective in the law. And the law, you know that the Dutch guys in the Netherlands, they have sued the government, they have sued the Shell because they are not delivering what they promised. So that's for me the first fact that, Europe will be delivering and ahead of the others. Number 2, the Fit for 55, it's 90% good, 90. And still tend to be brushed and polished, but is creating a pie that is like 8 times the pie that exists today. Number 2. Number 3, Europe, we import every year 700 billion euros of oil and gas. Me as a Spanish person, like you, Johan, you are working until the 12th of March to pay the oil and gas import bill. The day that we electrify industry, the day that we electrify transport, the 12th of March will become the 5th of February. So by just transforming the way we transport ourselves, we run industry, we'll be saving 1 month that today we're just paying the Middle East, Vladimir Putin and the others. So to your question, definitely yes, because it's all good for us Europeans.
Thank you. And a second question, perhaps more specific. You have an overview of the innovation projects, cases that they have been analyzed in the 18 No Energy. And in this field, I would like to ask, which kind of innovation, in which fields do you consider that they will be more promising in the coming years in the energy sector?
If I had to put my money today somewhere, it will be the storage, utility scale. I mean, today, base load is a bitch. And today we don't have a solution that is non-fossil based, except nuclear, for base load. And since we are going towards electrification, remember that Europe is consuming energy final use 13,000 terawatt hours. By 2050, will be like 9,000 because we'll be much more effective. But out of those 9,000, most of them will be direct electrification, all through the green hydrogen molecule. So, but storage is still something that we have not solved utility scale. So if I had to put today all my money, that will be in storage. Again, utility scale.
Okay, thank you, Diego. It's a pleasure. It's a pleasure. This experience and knowledge about the future and the situation of the sector. We don't have more time. Thank you, all the assistants, all the speakers, for being with us in this seminar. Just let me finish saying that if you have interest in the project and in advances in the different reports that we are developing inside the project, they are available on our web page. Thank you all for the assistance, and see you in the next seminar, we hope in a presential way. Thank you. Bye.